Good afternoon and welcome to your science review with Mr. Blaze. Today we're going to be working a vector addition problem that we began in class, so let's get to it. As you can tell, in our problem statement we had a person walk 35 to the east, 30 at an angle of 38 degrees, and then back 20. We need to figure out the length and direction of our resultant vector r. Alright, so let's get started. A, since we're starting over here, and we're starting over here because we know enough about this right triangle to solve it. So A is equal to 30, the length of this hypotenuse, times the sine of 38 degrees, this angle right here. B, the bottom side here, is similarly 30 times the cosine of 38 degrees. A is equal to 18.47 and B is 23.64. All right, now as you can tell, the backside, the upper side of our right triangle, A, is equal to little a over here. So let's go ahead and write that down. Now, this bottom side of our triangle, which we'll call big B, is in fact solved a little differently. Our big B is going to be equal to all of our horizontal displacements added up. So positive 35 plus a positive little b minus 20, because the 20 comes back. This gives us 38.64. Now we can solve for the length of r. We're familiar with a squared plus b squared equals c squared, which is Pythagorean theorem, and we can use that here. So a is our 18.47 squared plus our 38.64 squared equals c squared. That gives us 1834.2 equals c squared. Take the square root of both sides and we have c, the length of r right here, is equal to 42.83. And this makes sense because in order for the hypotenuse to be a possible answer for this, we need this value to be more than both a and b, and that's what we have. Now we need to figure out the angle. Okay, so the angle, we're going to use our trigonometric identities, where the sine of an angle is equal to its opposite side over its hypotenuse. All right, and we can solve for the angle by taking the negative sine of both sides. So we have our angle theta is going to be the arc sine of the length of the opposite side over the hypotenuse. And we have that for this angle here, where big A is our opposite side and our hypotenuse is C that we just figured out over here. So our angle theta is equal to the negative sine of 18.47 divided by 42.83, which gives us an angle of 25.55 degrees. All right. Now we have just solved for everything in the problem. We have the length of our resultant vector and its angle. We can write this as r with a little arrow over it equals 42.83 at 25.55 degrees. Okay. Now I know that was complicated, but trust me, you can get this if you try. I hope this helps. See you in class.